This is a story about Fin, AI customer support agent built by Intercom. Over the last year, we transformed the way we observe Fin and the way we operate it, and I'll tell you all about this exciting journey and all the ups and downs that we had along this journey. And I will also reveal a lot of secrets. In fact, I'm going to reveal a secret right away. A little bit of a drum roll. Yeah, ready? This is the actual title of the talk. And I'm sure Honeycomb wouldn't let me put it in the agenda, so I had to keep it on the second slide. But that's the thing. No one wants to talk about observability. And the funniest part is that's perfectly fine. And as we go through the story, you'll understand why. So I'm not going to waste your time introducing myself. I'll introduce Fin straight away. So as it says, it's #1 AI agent for all of your customer service. So let's take an example. Imagine you have a small business, you're selling some wood logs. Everyone loves logs. Logs are amazing. So you have yourself a nice website and have a little animation in here. Rustic wood logs, authentic, brilliant. And sometimes your customers, they still have some questions about your product. Let's call them end users. So they have some questions. So you put Intercom Messenger on your website and let Fin answer those questions, right? First, you have to give Fin some content, your knowledge base, your help center, with all the information about the product that you're selling, anything end users can possibly want to know about your product. And then end user just opens Intercom Messenger, types in a question, like, what should I do with all those logs? Submits the question, and then Fin is thinking. And it takes about 6, maybe 7 seconds for simpler setups, but it could take 10 seconds or more if Fin is configured with its own tone of voice. It has guidance, it has to do some actions, and it has access to tools. So sometimes it takes more time. But eventually, Fin starts streaming the reply back to you, back to the end user. And eventually, in a few seconds, we get the full answer in the browser. So we call this simple exchange between the end user and Fin an interaction. And in some cases, it takes a few interactions to actually answer the question, which is fine. When this conversation is answered, when the question is answered, we consider that conversation as being resolved. And of course, Fin customers care a lot about resolutions. Not only because they want their end users to have their questions answered, but because we charge them for resolutions and only resolutions. So if Fin, for whatever reason, wasn't able to give you an answer, a satisfactory reply, you don't pay for that. And you might be wondering, okay, so what's Fin's resolution rate, right? How often does Fin answer those questions correctly? A little bit of a drum roll. There's going to be a big secret. This is Fin's resolution rate. It increases by 1% on average every month over the last 2 years. And this is across all of our customers, no tricks. Everyone who uses Fin, all the data processed, and this is the resolution rate. So I think it's 65% at the moment. Top secret, right? Oh, of course I'm being cheeky. It's not a secret at all. We have this on our own website. And the reason is not only because we're proud about this achievement, but because that's what our customers care about, right? That's the thing that they're interested in, or at least that's what we thought. Well, it turns out our customers not only care about resolutions, but they also care about how fast those interactions with Fin are. So earlier this year, we started to receive complaints from the customers and prospects and buyers, and they were saying like, oh, Fin is slow. It's painfully slow. And this came as a big surprise to us because we actually did a research in production, and the outcome of that research was that increasing Fin's latency increases resolution rate. And don't get me wrong, we didn't slow down Fin on purpose to increase the resolution rate because end users, they wouldn't like that. No one wants to wait for a long time. But why were the customers so obsessed about speed as well? Like customers, potential buyers, why were they complaining? So let's take a look at that interaction that we had with Fin earlier. Why was it so agonizingly painful to wait for the answer? Well, because we knew the answer up front, right? Like, it's the only thing that you can do with logs. You just exterminate them with fire. So psychologically, when you know the answer, it's much harder to kind of wait until Fin comes back with a reply. So let's do a quick recap. We've just learned what Fin is from customer perspective, right? They care about their resolutions a lot, but they also want Fin to reply quicker, especially when the customers and potential buyers, they evaluate Fin and they know the answer up front. This is all our customers really want to talk about. And you know what they don't want to talk about? You know what they're not interested in at all? Stuff like logs, metrics, observability, open telemetry, data pipelines, none of that is interesting to them. And that's perfectly fine. So when we got the news about customers complaining about speed, everyone ran to engineers. We have to fix it. We have to make Fin fast. How are we going to do this? So now let's take a look at Fin from the engineering perspective. I don't know if I can share this. It's a big secret. Well, I guess I'm gonna have to do this. This is what Fin looks like from the engineer perspective. And I don't expect you to read all the labels, it's just from our internal documentation, but the point that Fin is a highly distributed and complicated system. There are multiple network requests and background jobs and token streaming here and there. All of it is involved in processing a given Fin interaction. But not only that, Fin is also distributed across the org chart. So we have this little piece of instrumentation that any code we run in production, it's annotated with the team name that owns that piece of code. So 19 teams are responsible for processing a given Fin interaction. And those teams, oh, let me tell you, they don't sit still. Those 19 teams are pushing changes like there's no tomorrow. So this is our typical Friday. And I think we deployed 50, maybe 70 times per day. So every line is a deployment, and we have several pages of those deployments. So Fin is a living distributed system, both across the infra, but also across the org, with the changes made to it every day. So as soon as we heard the news that Fin is slow, everyone got busy. And in every of those 19 teams, there were engineers that were like, hey, I know where the problem is. I know our systems inside out. So PRs were flying left and right, like lots of stuff were merged, everyone got busy, and everyone felt happy about themselves because we were really improving things, right? But somehow, our customers and prospects were not happy still. Outrageous. We did all of that brilliant work. What's the problem? Surely Fin must have been a lot faster by now, right? What customers were experiencing on their end, that Fin's end-to-end latency from customer perspective to the actual transactions that we were trying to optimize. So let's take a look again at those transactions, those network requests, background jobs, all of that stuff. Let's take a closer look, but let's put them in chronological order on a time axis. And you might say, well, probably it looks like this, right? We just have a few transactions, they're perfectly aligned, and then at the very end, we stream the tokens back to the messenger. All good? Well, it's a little bit complicated than that. Well, and maybe you say, maybe it looks like this. Maybe we have a few transactions, they're not perfectly aligned in time, that's fine, but we still stream the tokens at the very end, right? Well, it's not that either. It's slightly more complicated. It looks more like this. So some of the transactions, they're not even involved, they're not even started by the time the tokens are already streamed back to the end user. And you probably already guessed, to understand a system like this, you do need distributed trace. So that's exactly what we built. But not only we created a span per transaction, we also added a root span that represented that time end-to-end latency, exactly the time that you were waiting for Fin to reply from customer's perspective. So we start the timer as soon as the user posts the message, and then whenever the tokens are streamed back to the messenger, we stop the timer, and we call this time to first token, or end-to-end Fin's latency. And this was great. Finally, we could fully empathize with the customers, right? We knew exactly the way they felt when they were waiting for Fin to reply. But unfortunately, not everyone were happy with this new telemetry. Remember those engineers? Well, they were not happy at all because they couldn't relate to the new telemetry. When they were looking at those new spans, they could figure out what exactly was slow. They could answer the question of what was the end-to-end latency, but they lacked the details to be able to understand why. So we had a signal that answered what. The question that we knew was what was the true latency from the end user perspective, but we couldn't answer why. And the traces were just not detailed enough to answer this question. So why our initial attempts to make Fin faster didn't make customers happy? To understand this better, let's take a look at this Fin interaction again. So now that we have this time to first token, root span, repping the whole trace, but what really counts towards the time to first token? Well, we have to think about those elements of the critical path, right? Only those things make impact towards the end-to-end latency. Everything else that happens in those transactions, like this, and even this, none of that matters. So getting detailed visibility into the critical path is what matters to be able to answer the question of why. So we need to look at those things. So we got back to the drawing board. We did everything from scratch. This time around, we took our existing backend traces and connected them into a distributed trace with the time to first token on top of as a root span. So now we measured it on the front end, and this new span truly represented customer-centric signal and was finally connected to our detailed auto instrumentation, making it an engineering-centric signal at the same time. So our new traces were able to answer what was the Fin latency from customer perspective, but also crucially, why that latency went up or down. So armed with this new telemetry, we got back to work. Tons of meaningful optimizations were applied. Now engineers were able to formulate a hypothesis and see real-time impact of this change to the only thing that mattered, end-to-end latency. And in particular, I'd like to tell you about one optimization that one of my brilliant colleagues worked on, an optimization called eager request. And it's really important to understand the way it works because it'll play a key role at the end of the story. So here goes. Let's take a look back at this new kind of trace that we have. So we have time to first token that wraps that end-to-end latency. And somewhere in our transactions, we eventually hit the LLM, right? So we make that LLM call and then stream the tokens back to the end user. But there's a lot of lengthy stuff going on before we get to LLMs. Like we have to store everything in the database, fetch some metadata about the end user, maybe find more relevant content, lots of different things. So can we make a shortcut? Can we take a shortcut and speed things up? And that's what we did. So even before we save anything to the database, we immediately start processing with LLMs. In the meantime, normal request continues. So the flow goes on. And at a certain point, normal request says, oh, you know what? All good. Payload matches. We can send the eager request response back to the end user. Awesome. So this optimization helped us to shave 2 seconds off of the median response time. Brilliant. So this was an amazing, thank you. This was an amazing improvement, and customers loved it. And we liked it too. But we also wanted to make sure that we protect this optimization from further degradations. And for that, we had to follow the Beyoncé rule. Does anyone know Beyoncé rule here? No? Yeah? Anyone? So this rule postulates, if you like something, you should have put an SLO on it. Well done. And of course, that's what we did. So with all the hard work that we've been put into the system, an excellent speed improvement with eager request, we had to ensure that we stay on top of this new baseline. So we created an SLO, and over the last year, we had ruthlessly reacting anytime we were about to deplete the budget. I'm not going to go into details, but we had about 13 different degradations over the last 6 months. And half of them were related to LLM vendors, but half of them were related to our own changes to the code base. And there's one thing that I specifically love about SLOs in Honeycomb is that the correlation analysis thing. This is amazing because it reveals one secret about Fin. Do you remember this chart? Like when the resolution rate goes up by 1% on average every month? Cue in the drum roll. Oh boy, I don't know if I can share this, but here goes. Well, there's no secret. Of course, there's no secret. We just run hundreds and hundreds of A/B tests, and every A/B test increases the resolution rate by a decimal point, but in aggregate, you're kind of able to achieve this outstanding effect over the last 2 years. The fun fact about A/B tests is that, you can see its impact on SLO, like, oh, control arm has this representation in the outliers group and the treatment is much better. So you get this real-time feedback of how a given A/B test impacts your SLO. This is amazing. And that's how you get to this. That's pretty much the only way. There's no smart move, there's no tricks, there's no heuristics. No, it's just a hard work of A/B testing every tiny change, even on just UI thing. You have to A/B test that as well. So the fun fact is that we have so many A/B tests that we have to build a system on the side that every time we check the attributes and expire the old ones. So over the last month, we accumulated like over 100 of A/B tests. And this could have been a happy ending. Could have been the end of the talk. Like customers, happy, we have customer-centric signal, we can deeply empathize with them whenever they feel that Fin is slow. We can feel it as well. We can surface that signal in Honeycomb. We know all about it. And engineers are happy as well because we have that super detailed telemetry that enables them not only to answer the question of what, but also answer the question of why. And of course, we follow the Beyoncé rule. We have an SLO, like, it's all good. But we forgot about someone. Any guesses? Who could that be? Anyone? Like, whom we forgotten?
Business owner, engineer.
Right in the money. Brace for impact, because finance enters the room. And when finance enters the room, they mean business. And like they mean business figuratively, but also quite literally, because business is the only thing that finance cares about. Do you know what they don't care about? Open telemetry, traces, logs, metrics, observability, well, unless it's the cost of observability tooling. So none of that is on the table. None of that is even part of the discussion. Instead, finance cares about scary words like gross margin. Oh my God. They care about the word like forecasts. Oh, Jesus. So why were they sad? Why finance came to us? Well, remember that eager request thing? Yeah? So when normal request confirms that we can use eager request response, that's all good, right? But when the normal request processing does affect the payload and the prompt changes in the process of following the normal request, then we can't use eager request response. And in this case, all of that LLM capacity that was used in the eager request is all wasted. All of those tokens that we consumed. And by the way, we hit like LLMs 20 times for a given interaction. 6 different models across multiple different vendors. So there's a lot of money in there. By the way, any of you run LLM at scale? Raise your hand. Yeah? Nice. So you know how expensive that stuff is. Just unbelievable amount of money. And that's exactly the reason why finance wanted to talk to us. Because while building deep empathy with the customers and speeding up Fin, we unfortunately accidentally made finance sad. So we had to fix this cost issue no matter what. That's the business, right? That's the only thing that is important. Well, luckily we had distributed traces already, so we were able to run various different complicated queries, pinpoint where the inefficiency were, where the payloads didn't match, where we could improve things, and eventually we got the cost down. But we had to validate the impact, right? We had to make sure that we actually moved the needles as far as finance concerned. Luckily, we already had all the transaction logs and all the LLM requests and all the LLM costs in Snowflake, our data warehouse. Do we have anyone from Snowflake? No? I love the tool, amazing. But why did we have all of that there? Well, because that's exactly what finance were using to assess the LLM cost, right? Cost per resolution, cost per involvement, all of those important business metrics. So one of my amazing colleagues, he wrote a SQL query, like a 1-page long. And we got ourselves a nice chart going down, confirming that we actually managed to significantly reduce cost per involvement and reduce the LLM waste. And raise your hand, who likes charts going down? I love charts. In fact, I don't go to work for money. I go to work to make changes and see my charts going down. However, there's a problem, right? The problem with this query is that it just unfortunately takes 1 minute to complete, 1 minute to run. And if you want to group by certain attributes, well, good luck with that. And that's assuming you even have that SQL query, right? But the most horrific truth is that if you make a change to the system and you want to see the impact, then you have to wait for 2 hours to refresh the data in that table in Snowflake to be able to run this query, right? And I guess it's fine if finance evaluating the reports like monthly or quarterly, it's okay for them to wait a little bit. But for engineers, for operators, we can't work on a monthly basis. We need real-time feedback, right? If I make a change, I want to see my chart to go down right here in front of me, right now, right? So what did we do? How did we solve this problem? It's the same story all over again. We just took the business-centric signal and we added it to the same place where we had our customer-centric signal, right there on distributed traces. So now we had Fin interaction cost rolled up to the root span. And as both normal and eager requests are part of the same distributed trace, whenever we had a problem with eager request, whenever it was inefficient, we immediately saw the impact of it in the cost per interaction. In real time, right there in Honeycomb, right? We didn't have to wait for hours to run the SQL query in Snowflake. But it gets even more exciting. As soon as I propagated this cost to the traces, I was curious, like I was curious. I wanted to take a look at the LLM costs in Honeycomb. So that's what I did. And I noticed a weird thing. Like, why is cost per interaction goes up and down like this? It's supposed to be stable. There's not a lot of variance, or at least that's what we thought. And then, because I looked at those traces for so long, I kind of remembered, oh, this cadence of change kind of matches the switching of the LLM providers. So to protect Fin availability, we have a backup provider for every model we run in production. There's a person sitting in there who's in charge of that thing. Hi, Kaden. Yeah, so we switch LLM providers at runtime automatically based on certain criteria. One of them is latency. So if one provider slows down for whatever reason, then we switch to a different provider. So that was my hypothesis. So I ran a chart to validate it, and indeed, the spikes of change in LLM providers at runtime exactly match the spikes of Fin interaction cost. Great, so probably I figured that out. But also I noticed another curious thing. It turned out that different providers had drastically different price. Aha, so that's why Fin cost per interaction goes up and down like this, right? We switch provider at runtime, and suddenly the cost goes up or down based on the cost of that given vendor. And I could have stopped there, right? Big deal. One provider charges one price per token, another provider charges another price per token. Free market, do whatever you want. But being a responsible operator, I decided to ask another why question. And I actually went back to the source data with the prices per token. And it turns out that both providers charges exactly the same price. There's no difference. So how come we see this? Why the price is different based on which provider we use? So then we plotted all the token fields we have. And we have like prompt tokens and completion tokens and some other tokens, like many, many different types of tokens. And every token has a different price. But it turns out that the prompt tokens specifically, for some reason, they were different across providers. And that didn't make sense at all because the prompt is exactly the same, right? So the number of prompt tokens should be exactly the same. It doesn't really matter which provider you route that request to. And as it turned out, a few weeks before, we activated prompt caching on one of our providers. And as a result of that, some tokens were cached. But for some reason, instead of reporting all the prompt tokens as before, this provider started reporting only uncached tokens. So see how before August 3rd, both providers show exactly the same number of prompt tokens. So as a result of this, our cost estimations for that provider were significantly lower than they were in reality. So right there and there on the spot, I proved that the data available is not the same as data observable, because all of that data, all of the costs, all the LLM requests, all of it was in Snowflake. But given how hard it is to query, no one ever played around with it. No one was just curious enough to ask all of those questions. In contrast, having all of the data in Honeycomb enabled me to spot weirdness in cost per interaction, those spikes, and ultimately investigate this and figure out this issue. So we shipped the fix. We fixed the number of prompt tokens. It was reported now correctly, but then we had to run a massive backfill in Snowflake to make sure that finance is looking on the updated numbers as well, right? Because that was the most important thing for them. Needless to say, after this experience, I knew we absolutely have to stay on top of cost per interaction. Us as in R&D internally, not finance, us engineers, operators. And we really liked our new cost numbers and ability to discover things like this. And when you like something a lot, what do? Of course, we put an SLO on Fin cost. Now we had another SLO. And as you can see, it went down a little bit and went up. So we already had one degradation, which we successfully fixed. And now our compliance trends up, and hopefully we'll catch up with the threshold. Great. So now we had customers happy because we surfaced signal, customer-centric signal at Fin end-to-end latency, which was important to them. We can now empathize with them deeply because we know exactly how Fin is slow. We know exactly how they feel. And our business is happy too because we surfaced business-centric signal. And we are able now to empathize with finance team and track things that are important to them, like cost per interaction. And look at those engineers. Oh my God, they're so happy. They can finally not only see that signal, right? But they can also answer the question of why. Why that signal went up or down? And now you might say, well, Kesha, this is a nice story. Happy for you. Not sure, though, if it applies to my company, right? Everyone have different things. Probably won't work for you. Well, let me tell you about Rasmussen safety model. So this safety model explains how socio-technical systems can drift into danger by operating within an envelope defined by 3 boundaries. When you cross your performance boundary, your customers are sad because the product is either down or slow, they can't use it, they're not happy. When you cross the economic boundary, things are getting expensive to run. And the finance team is sad and they suddenly wants to talk to you. No one wants to talk to finance team. It's really scary. And when you cross the workload boundary, your engineers are getting sad as well because they have too much work to do. But for a regular operator, those boundaries are elusive. It's really hard to see them unless you're coming close. In fact, too close. You can only see them when you cross them, when it's too late. But they do exist. Your customers do know when things go south. Your business know what the gross margin should be. You know why? Because they already promised that gross margin to the investors. They know exactly what the number is. It's in the docs. And honestly, I don't know a better telemetry than Traces to be able to combine customer-centric signal, business-centric signal, and attach all of that to a detailed telemetry that will help your engineers to answer all of those questions. Not only what was the end-to-end latency, what was the cost per interaction, but also why those things change up and down like this. Using the exact same data, same tool, in real time. So now it's the time to quote one prominent, well-known observability leader in the space. The art of observability is to surface real operational boundaries, right? This is our job as observability engineers. Yeah, I love to quote myself. I think it was the best. This is our job as observability engineers to surface those boundaries and to make sure operators can answer what and why at the same time. Our job is to create a data set where all stakeholders, business, customers, engineers, they can sit down together, look at the same data, and make a call on what to do next. This is something I call the last mile of observability. You can't buy this off the shelf. You can't read this in the book, or maybe in the second edition. Instead, you should build a deep connection with all of those stakeholders and make sure you surface the signal that is important to them. That's the key to make those elusive margins and boundaries visceral, unavoidable, so that operators, they can't ignore them. And the good news is that you only need one thing to make that happen. One thing, really. Little drum roll, and... No, not that. This is what you need. Empathy is all you need. Because in the age of AI, it turned out, ironically, that empathy is by far our biggest superpower. Thank you so much. This is it.